So we will look at the second part of the lecture one. I have put this in few parts because of the size of the files, really, nothing else. So so in here we will continue to look at PFI or fuel system. PFI is port fuel injection and direct injection. So now this picture shows shows how fuel is injected through a nozzle. So both PFI and DI or direct injection have similar injection technologies. Right. So we'll look at a PFI mechanical or port injection system. So that's your inlet manifold. That's your inlet airflow system. So you have the throttle body, and in here, what you can see is now there's a injector is operated through using a flap valve. Now, when you open the throttle here, this flap valve will go up. That means it will open up the fuel lines here. So that is connected to the fuel regulator, pressure regulator, and depending on the position of this flap valve, the amount of fuel that is coming into the system changes. So the larger the opening here, the more the fuel that is coming into the fuel injector. So for idle operation, it has another injector, which is that's called the cold start injector. So it's not actually for idling; it's for cold starting. So when you cold start, when you cold start, this special cold start injector will operate and enriches the fuel and enriches the air fuel mixture. Thereby you will have a rich mixture, so it will improve combustion or improve ignition initially. So this picture shows you gasoline fuel injection system and its components. So you will have now this is a common rail system. Now that's a picture of a common rail system. This is the fuel injection pump actually. So this is the pressure pump. So that pressure pump keeps this rail, or that's basically a tube, and on that rail there are distribution pipes which take the fuel into the injector. So the purpose of the common rail is to keep the fuel at the pressure, at the highest pressure for all the injectors. So in the system, in the fuel injection system, you have a fuel filter, fuel tank, and there's an evaporative emission sensor connected to the fuel tank, and there's a pressure regulator as well. And that's the ECU or the electronic control unit controls the valves here basically, and the ECU will get signals from the crankshaft speed sensor, speed position, and camshaft speed position sensor. That's the camshaft speed position, and throttle position, that's the accelerator pedal, and then there's a vehicle speed sensor as well, so it will tell about the vehicle speed as well, and then boost temperature sensor and air temperature sensor, coolant temperature sensor, and oil temperature sensor. So all these sensors feed signals into the ECU. So ECU, based on looking at those signals, it determines the amount of fuel that has to be injected onto the system. So depending on the amount of fuel that is injected onto the system, it will open this fuel injector valve for a certain period of time. So because this is at a common fixed pressure, so that that fuel injection time will determine how much fuel is injected onto the cylinder. So if you compare PFI versus DI, port fuel injection versus direct fuel injection. So port fuel injection has an increased lag. So direct fuel injection is impromptu. It's quicker. There's no lag. But PFI is less complicated. DFI is or DI is more complicated because DI needs to have higher pressures than PFI. And PFI creates a less demanding environment, and direct injection creates a higher demanding environment. So the one of the problems in direct injection is knocking can happen in direct injection very quickly. So you need to control knocking in direct injection. Then compression ignition versus spark ignition. In compression ignition, ignition occurs when temperature of the compressed air is above the auto ignition temperature. So a fuel has an auto ignition temperature, and so fuel is directly injected into the cylinder or the pre-combustion chamber. And the type of combustion there is diffusion combustion. It's a diffusion flame that has been created, and this picture gives you an idea of a diffusion flame. Now that is your premix flame. That's a diffusion flame. Premix flame means the air fuel mixture is igniting. So the flame front will propagate very easily to the air fuel mixture. But in a diffusion flame, what you have is you have airstream on one side, and the fuel air is on one side, and fuel stream is going into the air, and the combustion front or the flame front is at the boundary of the fuel spray and the air. So so premixed combustion, you can consider that to be a slightly cleaner sometimes. So in spark ignition, the ignition is controlled by the spark at the time of the ignition is controlled by the spark. So fuel is normally mixed with air before the cylinder. So and spark ignition, it's a premixed flame. So you need to know that in a compression ignition engine, the flame is a diffusion flame, whereas spark ignition engine, the flame is a premixed flame. So this video, I'm not going to I'm not going to show this now, but you can look at this later. Just play this and it will give you a better idea of how the spark ignition and compression ignition work. So if you compare spark ignition to diesel or compression ignition, in spark ignition, the fuel is ignited with a spark, whereas in diesel combustion or compression ignition, the fuel is ignited due to the pressure and the friction forces and the temperature that is generated there. So what you need is an environment where the temperature is above the self-ignition temperature of the fuel. So the self-ignition temperature of diesel is less than the self-ignition temperature of petrol. And in spark ignition, the volume compression ratios are about from 8 to 12 is to 1, and in compression ignition you have volume compression ratios of 12 to 24 to 1. So between 12 and between 12 to 1 and 24 to 1. high compression ignition engines. So in spark ignition engines, therefore the efficiency is lower than that of compression ignition engines, just because you can't withstand high compression ratios. And spark ignition engines have a slightly higher fuel consumption than the fuel consumption of diesel engines or compression ignition engines. But on the other side, spark ignition engines have lower noise. Compression ignition engines have higher noise. So then we'll look at the ignition system of spark ignition engine. So you see this system. That's your battery. That's the ignition coil. So what the ignition coil does is it increases the voltage difference. So this acts as basically a transformer. So it gives a very high voltage across the spark plugs, and then you have a capacitor as well. So what the capacitor does is capacitor creates it accumulates electrical charge and it releases it at a very short period at a very high voltage. So that's what the capacitor does. And then there's the distributor. What the distributor does is it selects what plug it has to what spark plug it has to ignite. So this is connected to the camshaft basically. Therefore it knows where the cam position is, and depending on the cam position it tells when to ignite. So what it does is, when a very high voltage is given to the spark plug, what it does is there are two contacts here and there's an air gap here. So there's a spark generated between these two contacts. So when high voltage is supplied onto this system. So this usually you have an electronic ignition control module as well in the present day cars, and usually in the old days. The ignition advance, what is meant by ignition advance is the position at which it starts ignition. was it was decided by the position of the distributor of the car. So the distributor could have been you could rotate the distributor and change the ignition advance in the old cars. Nowadays you can't do that. Basically it has fixed position, and ignition advance is determined by the electronic control system. So basically it has a now this is the switch, this is the battery, this is the electronic ignition module, and this is actually the vacuum advance for the ignition system, and then that's the distributor. And then we'll look at the piston assembly. In the piston assembly, you have the piston, then you have 3 oil rings, and then compression rings as well. So the compression rings are spring loaded so that it closes the gap between the cylinder and the piston. And then this is not the piston, this is the pin, and that is the connecting rod. And these are bearing inserts. So these bearing inserts act as bearings actually. It will provide or facilitate a low friction surface. And this is the cap, and those are the nuts. And the engine block, this is the engine block. So inside the engine block, there is three-cylinder engine, the six-cylinder engine. In the engine block, you have the cylinder and the sleeves as well in some engines, and then you will have the cooling channels around it, cooling channels, and then you have mountings for various components in the engine. And then you have the oil system. In the oil system, what the oil system does is it takes oil from the sump to the moving parts of the engine. Basically, it has a it has a oil pump, so normally a gear type pump. So that is for positive displacement, and then a control valve, and then there's an oil cooler system as well. So usually oil is sucked up from the sump and it's pressurized, and it is injected onto the camshaft cylinder and to the cylinder block. And some of the air is some of the oil is actually going between the um, so, rings, oil rings as well, and it needs to oil the pin, the gudgeon pin of the piston as well. Then you have the engine coolant system, engine cooling system. So you have a heat exchanger that is called the radiator normally. Warm water from the engine is coming into the radiator, and then this is a cross flow heat exchanger basically. So water is moving inside these pipes from top to bottom, and then it is fed onto the system, uh, fed onto the engine here. Then you have a water pump as well. Then you have a reservoir that will keep the coolant level at reasonable position. In some engines, in some cars, you will see that some of the hot water inside the engine is used to heat the passenger cabin as well. In certain cars, you will find electric heaters. In certain cars, in European cars, basically, you will find engine. You will find another radiator, small radiator system that will allow the cabin air to be heated using this small radiator. And then you have the exhaust system. The function of the exhaust system is to expel the air from the cylinder to the atmosphere. But before that, you have to you have to curb two things. One is the noise. The other one is can reduce emissions a little bit more. So unburnt hydrocarbons and carbon particles, etc. You can you can reburn them inside the catalytic converter, and you can release the yeah release a cleaner exhaust air onto the system. So when the air- the exhaust air comes from the exhaust manifold, so you have an O2 sensor in the exhaust manifold, and it will tell you whether you have unburnt hydrocarbons in there. So if it is there, the catalytic converter kicks in, and it burns it a little further, and it allows allows it passes the air into the muffler area of the exhaust system, and then it sends it to the resonator, and then it expels the air through the tailpipe. And in new exhaust systems, you will also find that you'll also have around here you will see uh, you will see urea solution injection onto the system, so that NOxes will be reduced as well. And this picture gives you two-stroke and four-stroke engine cycles. So in the two-stroke and two-stroke engine cycle, what happens is it is you normally have a port there. So what the port does is it allows air come into the chamber. So you don't normally have an oil sump here. So air is coming through the port and it will be compressed by the piston itself, and then it is transferred onto the cylinder area through the port. Okay, and then when there is an operation where when the cylinder goes down, the air will be expelled through the exhaust port here. So at the same time, when the cylinder goes down, it will close the intake port as well. So the intake port is closed when the cylinder is at this point, and then you know that exhaust gases will be expelled from here. When the cylinder goes up, when the cylinder goes up to this level, this port will be open, and that port will be the exhaust port will be closed, and air is coming into here. So and then there is another transfer port as well, which will allow some of the exhaust gases to come in here. In four-stroke engines, you have, as I said, you have the suction, compression, power, and exhaust. So suction is called induction stroke, inlet valve, open sky, exhaust valve is closed. Then you suck the air inside. Then both valves will be closed at the end, and then you have the compression stroke where you compress the air fuel mixture or the air in the compression ignition engines, and then you have the power stroke where at the top of the compression, so you ignite the fuel or you spray the fuel or you ignite the air fuel mixture. Then, then the piston will be moved down, and then the piston will come up due to the inertia of the system, and then you open the exhaust valve and it will be expelled outside. So the two-stroke engines it has one power stroke for every revolution. In four-stroke engines you have one power stroke per two revolutions. So and it tells you other things as well. Two-stroke comparatively high power to weight ratio, four-stroke comparatively low power to weight ratio. And two-stroke, though it is less clean and it is less efficient in fuel. And two-stroke engines are not used in automobiles anymore, and they are only used in small apparatus, etc. So usually the day-to-day car you find they are always four-stroke engines. Yeah, thank you for listening to my lecture. So I will see you again.